Good day, students. Today we want to calculate de-Broglie wavelengths when the velocity of the electron is unknown. Please don't forget that when electron is moving in a wire, there must be supply of current in the wire. That is, there must be potential difference between the ends of the wire. Okay, before then, you should know that when potential difference is between the end of the wire, kinetic energy is taking place. There's energy due to motion. And when there's energy due to motion, the formula of kinetic energy is half mv squared, which will be equals to the electron volts. You see electron volts because when there's movement of electron in the wire, when the supply of current, there will be motion taking place. That's why we have to equate the kinetic energy to the electron volt, because there's potential difference between the ends of the wire when there's supply of current. Now, when you have that, your kinetic energy will be equal to half mv. This mass of the electron, velocity of the electron squared equals to electron volts. We are given electron and we are given the potential difference. Okay, now what we don't have here is the velocity of the electron. Now make it m1 times mev squared as m subscript a v subscript a squared over 2 equals to electron volts. Cross multiply, you having MEVE squared equals to 2EV. Divide both sides by ME times ME. You are left with VE squared equals 2 electron volts over mass of the electron. Find the square root of both sides. These two cancel the square roots. You are left with velocity of the electron to be equals to square root of 2eV over mass of the electron. Don't forget that our V equals 100 volts. Now we have square root of 2 times what's our electron? 1.6 times 10 to the power minus 19 times 100. Our V is 100 divided by mass of the electron. S3 EM is taken as mass of the electron, which is equals to 9.11 times 10 to the power minus 31 kilogram. Okay, I now have 9.11 times 10 to the power minus 31 velocity of the electron, because when you multiply 2 times 1.6 times 100, that's 320 times 10 to the power minus 19 divided by 9.11 times 10 to the power minus 31. Okay, now velocity of the electron equals 320 divided by 9.11. When you press your calculator, you have 35.13 times in indices 10 to the power minus 19. This division is negative, minus 31. This division is negative, stand for negative in indices. The velocity of the electron equals square root of 35.13 times 10 to the power minus 19. Negative and negative is positive, plus 31. Velocity of the electron equals square root of 35.13 times minus 19 plus 31, that's 25. 10 to the power 25. Velocity of the electron, when you find the square root of this by pressing your calculator, please, when you are pressing your calculator, let's put the bracket here so that the square root can take over of every value. So, okay, let open bracket and close, put the value inside and look for the spread the square root. Let's have the electron now. Minus 19 plus, let's look at the very minus 19 plus 31 is let's see 31 minus 19. Borrow 1 to here, that's 2. I mean that 2 minus 1, that's 1. So it's 12. It's 12. It's 12. Now when you find the square root of that, you have 5.927 times 10 to the power 6 meter per seconds. Now you have gotten the velocity of the electron. Let's go back to the formula of the de-Broglie wavelength. De-Broglie wavelength equals Planck constant over mass times velocity of the electron. What's the Planck constant? But this is what we are looking for. Let's put it as unknown. De-Broglie wavelength. Now what's Planck constant? Planck constant is 6.63 times 10 to the power minus 34 divided by mass of the electron. This mass of the electron. Mass of the electron is 9.11 times 10 to the power minus 31 times velocity of the electron 5.927 times 10 to the power 6. The Broglie wavelength equals 6.63 times 10 to the power minus 34 over 9.11 times 5.927. When you multiply that, you are having 53.995 times 10 to the power minus 31 plus 6. Indices calculation is positive when you are raising it to power. Wavelength equals 6.63 divided by 53.995 times 10 to the power minus 34 times 10 to the power minus 31 plus 6, that's minus 25. Wavelength equals the Broglie wavelength divides 6.63 divided by 53.995. When you press your calculator, we are having 0.1228 times 10 to the power. We have looked for division of these numbers, these decimal numbers. Now let's concentrate on the power. Okay, let's apply the indices. 10 to the power minus 34. Division is negative. This division is negative. Before you now bring this minus 25, minus 25. Okay, wavelength, the Broglie equals 0.1228 times 10 to the power minus 34. Negative and negative as positive 25. Now the Broglie wavelength equals 0.1228 times 10 to the power minus 34 plus 25, that's minus 9. Okay, meters. The Broglie wavelength is in meters. Now when you shift one, when you are shifting from negative from the left hand side to the right hand side, you'll be introducing negative at the power. But if you are moving from right to the left, shifting, let me say you're having 2, 5, 5, 2, and you're shifting like this 1, 2, 3. It will now be 2.532 times 10 to the power 3. Okay, but if you are shifting to the left, you introduce negative. Now I shift like this once. The Broglie wavelength equals 1.228 times 10 to the power minus 9 minus 1, which is equals to 1.228 times 10 to the power minus 10 meters. Now the Broglie wavelength is approximately, let's change it to 2 decimal places, 1.23. So this 8 is more than 4, round it as 1, add it to round it up as 1, add it to these two, 3 10 to 3 times 10 to the power minus 10 meters. This is the end of our class. Please subscribe to my channel so that I can have access to the latest video. Have a wonderful day.